Okay, guys, this standard deviation or variance is just another tool to determine the tendency of a data. Okay, um, and this standard deviation or variance can be calculated from all those kinds of data that we have for the mean. Like we can have the raw data, the frequency distribution, or the group frequency distribution, from where we might have to calculate this standard deviation or the variance. But let me tell you very quickly that what does this standard deviation mean. Now, suppose you have, I'll be taking very easy examples here, okay? Now, suppose you have, let's say, 0, 10, and 20, okay? So what is the mean of these three observations here? Can someone tell us quickly? Yes?
10.
The mean
10.
is 10, okay. Now, let's say we have 5, 10, and 15. So what is the mean in this case?
10.
The mean is again the 10, okay? Let's say we have 8, 10, and 12. So what is the mean here?
10, sir.
That is again 10, okay? Achha. And you can have 9, 10, and 11. This mean still remains the 10. And then you have 10, 10, and 10. So here the mean is again 10. So as a statistician, which data would you uh, prefer to have? You want to start a business or like whatever you want to do, which is you think is the most credible data over here on which on the basis of which you can make a very sound decision?
The last
10,
one.
10,
The
and 12.
last one. Why do you think the last one is the most credible data here? Yeah.
Because the difference between the values is 0.
So what does
Deviation
this?
from the mean is the least.
So
Yeah,
that
so the
means,
spread of data is very little.
yeah, exactly. And you have the most consistent values over here, okay? There is not much difference between the all the data from the mean, okay? So that is basically a quality of the data that we always prefer to have. For example, as a teacher, I would love to have a test where all of you mark, you get the marks like this, okay? Just 1 minute, let me, now, this is the best data we have here. So now what if we have like a large number of observations, and sometimes you have the same range of the data, and still the mean is the same. For example, you have 0, like 10 and 20, okay? Then you might have 0, 6, 10, 14, and 20. You see, the mean is the same, the range is the same, okay? You might have 0, 2, 6, 10, 14, 18, and 20. So you see that there are the range is the same, the mean is the same, but like so far you people have learned that okay, this mean is the same, and here the range is the minimum, so therefore this is the best data over here, okay? But you can have the situations where the range and the mean both can be same. So there you have to calculate this standard deviation to determine that which data has more concentrated values, okay? And when you are giving a summary to someone, for example, someone has assigned you you have got a project to for a particular company, let's say Pepsi Cola or whatever, there is any franchise or a company or a multinational that needs some certain kind of data. Okay, so obviously that company will not be needing the whole of the data. They will just be requiring a processed and a refined information on which on the basis of which they can make a decision. Okay, so for that purpose, where you will tell them, okay, this is the range of the data, this is the mean of the data, and then they will give the standard deviation as well. This is the symbol for the standard deviation, the sigma. Okay, so you will be telling them that, look, for this particular set of data, the range is this, the mean is this, and here is this standard deviation. Okay, so if the smaller is the standard deviation, the more concentrated is the data. You must note it down. The smaller is the standard deviation, the greater is the concentration, the lesser is the spread of that data. The more values are closer to the mean if you have a smaller number of standard deviation. Now, let me tell you how do we calculate that standard deviation. Okay. Now, this is very much related to the coded data thing. Now, suppose you have a data which is going to be, let's say, I'm going to take a small example here. Let's say you have 2, 4, 10, 16, and 18, maybe. Okay, this is your 18. Or let me, this will give me, I don't want to take the symmetrical data again. Just a minute. Let's keep here 11 somewhere here. Okay, and we have let's say 17 here. Now, please tell me quickly, what is the mean of this data? Chale. Find the mean quickly. So the mean here is 10.5. Okay. Now we'll be finding x minus the mean. That is, what is the deviation of all these values from the mean. Basically, we write it as xi minus the mean. Xi means like the first, this can be x1 minus mean, x2 minus mean, x3 minus, like the first observation, the second observation, the third observation. So this xi means in general, like one by one, you will be finding the difference of all these values from the mean. Okay, so now let's write these values. So this is going to be 2 minus 10.5 is going to be minus 8.5. Now, and the next one. Okay, these are the deviations of all these individual observations from the mean. If we have to find the mean deviation, if we want to find the mean deviation, and you keep the minus as minus and the plus and the plus, do you think that you will be getting a correct answer if you want to find what is a mean deviation here? Bacho? Suppose you have a situation where the data is 2, 4, and 6. Now the mean is 4 over here. Okay, this is your x, and then your deviations from the mean are going to be -2, 0, and 2. So what is the, if you want to calculate the mean deviation, um, so that would be sum of all these deviations over this n. So what is this sum of all deviations here? Bachcho, 0. So if the sum of all deviations is 0, that means the data is just like this, 4, 4, and 4. Because if the mean is 4, you see that the deviations are going to be 0, 0, and 0. So the mean deviation is going to be 0. So these minuses over here, they are going to make this an ambiguous case. So we have to get rid of this minus over here, okay? For that purpose, you will have to square all of them, okay? You will square them. Okay? I'm not going to square all of them. I'm just going to sum this up now. You will have to square them up, and then you will divide the square by the number of, this is the sigma x minus the mean whole square over n. Okay, so this is known as the variance. This is called the variance. Okay, if you take its square root, that is going to be, at the end you will take the square root just to minimize the impact of that square that you have taken to get rid of these minus signs. So this is the formula to find the standard deviation of a given raw data, okay, over n. Okay? So I just wanted to give you a basis that how do we have this formula for the standard deviation. Teachers normally don't give this all this detail. They just give the formula to the students. But I have tried to convince you guys that why do we have this formula for the standard deviation. Okay. Now there is another version for this uh, formula for the raw data. Please note it down. That can also be explained, but I will not. Okay, over n minus the mean square. This gives you the same result as, like, they both are the same. Okay, but these two formulas can be used when you have the raw data. Okay, when you have the raw data. Now please be very clear in the beginning. Okay, please remember sigma x square and sigma x square, these are totally two different things. Okay, let me explain you what do we mean by this. Suppose you have the observations. I'm again going to take a small example here. 2, 5, 7 and 9. Okay, the 16 plus 7 is 23. 23 uh 23, let me keep this 6. Okay, so the mean is 6 over here, है ना? 8 plus 7, 15 plus 9 is 24, over 4 is the mean is 6. Okay, so if you want to find x minus mean, I'm not writing that I sign over here. Okay, so that would actually mean that you will be like 2 minus 6 is minus 4 square plus 0 square plus 1 square plus 9 minus 6 is 3 square. You will have to find these values one by one, okay? And then you will add them. That will be your sigma x minus mean whole square, or the deviation square, the sum of the square. This is called the sum of the squares of the deviations. Okay, now suppose if you look at this, your sigma x over here is 24. And what is your sigma x square, guys? Can someone tell me what is sigma x square? Yes, sigma x square would be 2 square plus 6 square plus 7 square plus 9 square. Can you quickly tell me what is this going to be? This is 4 plus 36 is 40 plus 49 is 89, 90, 170. Is that 170? Yes. Okay. Now let's find the standard deviation through both the formulas. Now, one of the formulas tell us that, okay, this is going to be sigma x minus mean whole square over n. So this sigma x minus mean whole square is 16 plus 1 is 17 plus 9 is 26. Okay. So this is 26 over 4. And the mean was 6. That is 6. Oh, I'm going to, let me just find the variance in this case. Okay. So this is going to be this. It says 4. The mean was 6. Okay. This is 4 and 4 point whatever, 4.5 minus 36. This is a very bad example, in fact. Okay. So this is going to be minus 31.5. Let's
Sir,
find the
6.5 आएगा 26 over 4.
9.5. Yes. Okay. Now let's find this variance from here. Okay. So there is a square on it. So this is cancelled by this. I'm just finding the variance. Okay. So this sigma square is going to be the second formula for this is going to be sigma x square over n, and then oh, I'm mixing it up. Yeah, come on guys, you didn't tell me. I'm making a mistake here. I got confused. This only is, let me write this neatly. I was wondering that how come this standard deviation is coming in minus, because we have squared all of this. Okay, so this can never be in minus. So this was simply 6.5. No one told me this is going to be 6.5. Okay, now so your variance is going to be okay, this, and this. Okay, so we have got the variance. I don't need to find that. Okay, so this is your standard deviation here. Now the standard deviation through the second formula, that is going to be the square root of, here you have to find that like this is what you have to do in this case. Okay, you will see that you will get the same answer. Now there is a square root on it, there is a square root on it. Okay, so sigma x squared, that is 170 over 4 and minus mean square. Mean is 6. You will see that. Please tell me, what do we get from here? This is 470.
6.5.
Yeah, that is a square root of 6.5. So you see that through both the formulas, we have the same standard deviation. And if you want to find the variance in both these cases would simply be 6.5. Okay. The variance is used at times when you take the square root and the value becomes very small. So we just use this variance sign over here. Okay. And you will see that in upcoming distributions, we just use the variance rather than the standard deviation. Okay. Acha. Now, you need to write down the formulas for this standard deviation and variance. For the raw data, this standard deviation is going to be either you have sigma xi minus mean whole square over n, or this is going to be sigma x square over n minus mean square. Okay. When you have the frequency distribution, this formula would be, this variance would be the square root of sigma f into x minus x whole square, okay, over sigma f. Or the same formula can also be written as sigma fx square over sigma f, and then minus the mean square. Please look at this, and then we can practice some questions from here. In the next segment, I'll be showing you how we're going to apply these formulas. Let us try this second formula by taking a small example here. Okay. Now suppose you have, and by the way, you know that your grouped frequency distribution, the formulas are same. You only have to find the mid values over there. Okay. So there are just these two cases, raw and this frequency distribution. The frequency distribution covers that situation of the grouped frequency distribution as well. Okay. Now suppose you have 1, 3, 6, and let's say, let me just take these three values. Okay. And there is a frequency is 5, this is 8, and this is, let's say, 4. Okay, now let's find the mean. So you will have to have fx over here. Okay, so fx is going to be 5, 24, and this is 24. Okay, and for this standard deviation, you need to have a column for x square. This is 1, 9, 36. Then you will be needing a column for fx square. So this is going to be 5 into 1 is 5, 8 into 9 is 72, and 4 into 36 is going to be 144. Okay. Now we have 13 plus 4, that is going to be 17 observations. And this is going to be 48 plus 5 is 53. We don't need this. We need this. This is going to be 7 plus 4, 11. This is 2, and this is 2. Okay. Now, if you have to find the mean, you know that the mean is simply sigma fx over sigma f. So that is 53 over 17. And if you want to find the standard deviation, that is going to be, uh, you better use this formula. There's less working in it. If you want to find the other formula where you have to find those deviations, that takes a lot of time. Okay. So I'll be using this formula, sigma fx square over sigma f, and minus the mean square. So this is going to be sigma fx square is 221 over 17 and minus 53 over 17 square. So that is how you will be getting the standard deviation. Any questions, Bacho? Now, just one thing I want to add into this, because you know, you must be knowing how to find the standard deviation in case of the coded data. Okay. Remember, if you have your original data, that is the values of your x, and then you have got the deviations. Okay. So there is always a difference of this a between these two. Okay. Like when you go from original to the deviation, so you just add or subtract this a into that. Okay. But if you want to I mean, get the mean through this coded data, so you know you have to put this a back into the data. Okay. So you must be knowing what happens to the standard deviation when we are using this coded data. Look at this. Let's say you have there is again, taking an easy example here. Let's say you have 12, 14, and 16. Okay. And you have taken out 10 from all these values, and then you have 2, 4, and 6. Okay. So there's clearly a difference of 10 between these two observations. So if the mean over here is 4, the mean over here is going to be 14. What do you think? Would there be any difference between their standard deviations? Hmm? Look at the difference between these observations here. Isn't it the same? Yes
Yes,
or no?
sir. Like,
Yes. Okay. So this means, for example, this is your original data over here, and this is the new data y over here, where your y is basically, y is going to be x minus 10. Okay. So the mean of x is going to be the mean of y plus that a, which is right now 10 over here. But remember this forever, that their standard deviations will always be the same. If you have coded a data, then there is a difference of this A between their means, but the standard deviations, they remain the same. Please note it down, whatever is the kind of data, either it is the raw data or the um, frequency distribution or whatever, okay? There is a difference of this A in these two data, but the standard deviations, they are going to be same. Okay? In my
Sir,
next
are we
video,
saying that
yeah, yeah,
because
yes,
the
yes.
difference between the two values is the same? Sir, are we saying that the standard deviation is the same because the difference between all of the values is the same?
Obviously, because the standard deviation tells you that how deviated are the values from the mean, okay? So this is the same, either you take the original data or you take the new data. The observations, they are all deviated with the same uh, magnitude or same value. Either it is the original data or it is the new data or the coded data, in fact. Okay. So in my next segment, I'll be taking questions from the past papers rather from the book to practice this concept of standard deviation, this formula, in fact.